before we start with the scalar multiplication, I just want to refresh on the order, or the size of these. So if I'm looking at matrix A, how many rows do I have? 2. And then how many columns do I have? So that one is going to be, is going to be a 2 by 3. And that's how you write the order. Again, those will be questions on your test next week. What about matrix B? What size is it? How many rows? 2. And how many columns? 3. And then both C and D are what we would call square matrices because we have the same number of rows and the same number of columns. They each have 2 rows and 2 columns. Or you could just write it as 2. You can either do 2 by 2 or you just write 2. And that's just a refresh. So we're going to do scalar multiplication. So that 4 right here is called a scalar. That will be a question on your test as well. So whenever you're taking a number and you're multiplying it by a matrix or a matrix, that number is called the scalar. And you literally take that 4 and you multiply it by every element in A. Okay, so it looks like this. 4A is going to be 4 in front of my matrix. 4, 2, 0, -1, 3, -2. And it's just like distributing that 4. You just take that 4, you multiply it by every element in there. So our new matrix for this scalar multiplication, 4 times 4 is 16. 4 times 2 is 8. 4 times 0 is 0. 4 times -1 is -4. 4 times 3 is 12. And 4 times -2 is -8. And that is all you have to do for scalar multiplication. Does that make a little bit of sense? Okay. Using those same 4 matrices, I want you to do 2 and 3. Multiply C by 6 and multiply D by -4. C by 6 and D by -4. And you don't have to write it all the way out like I did with question number 1. I was just kind of showing you what I was doing. If you just want to write the answer, that's perfectly fine. So for number 2, we're going to take 6 and we're going to multiply every element in C by that. And we get 24, 0, 12, 6. Is everybody okay with that? Okay. And then number 3, we're going to go -4 times D. And again, I'm just showing all of my work. You don't have to write all this out. So we're going to get -20 and -8, and then +4 and 0. All right, let's see what else I got here. Okay, these are the same 4 matrices. I want you to try 4 and 5. So 4 is got a 3, and then in parentheses, C plus D. Excuse me. So you can either add C and D first, and then multiply them by 3, or you can multiply each of them by 3 and then add them. But remember, in order to add them, they have to be, what did we say yesterday? The same. Okay, so first of all, check and make sure they're the same. If they're not the same, you can't actually add them, but you can multiply by the number in front of the parenthesis. All right, so the first thing I'm going to do is I'm going to add first. C plus D, they are the same size. So remember, we just add each element. 4 plus 5 gives me 9. 0 plus 2 gives me 2. 2 plus -1 gives me 1. And 1 plus 0 gives me 1. And then I just take and multiply each, except for that's not a 4, that's a 3. Multiply each one by 3. That's 27. That's 6. That's 3, and that's 3. That's how we leave our answer there. And then for 5, because A and C are not the same, what we're going to do is we're just going to do 4 times A plus 4 times C, and we'll just leave it as 2 matrices that are being added together. So I take matrix A. I'm going to multiply every element by 4. So that would give me 16, 8, 0, -4, 12, -8. And then I'm going to multiply every element in C by 4 as well. That's 16, that's 0, that's 8, that's 4. And because they are not the same size, I cannot do anything else. And so I'd leave my answer just like that one. Okay, we wouldn't say not possible because we were actually able to multiply. But we can't actually go any further than that. Anybody have any questions?